just heard from Accenture around data and how important this is. So Mary is the senior data analyst for AWS, and also she's the president of the She Builds thing here. So Mary, over to you.
Thank you. Hi everyone, my name is Mary and welcome to this breakout session. Can you guys hear me okay? Cool. All right, in the next 30 minutes, I'm going to be talking about why a data foundation is important for generative AI. Generative AI represents a leap in artificial intelligence, capable of creating content, ideas, and data and code that mimic human-like creativity and understanding. While traditional AI primarily focus on analyzing data, recognizing pattern, and making prediction, generative AI takes this a step ahead by producing original content output based on learned pattern. Generative AI can transform industry. In the health industry, for example, we can now analyze patient data, be able to analyze patient data, and in an automotive industry, we can actually generate new engineering pattern and design as well. In the creative art, it can now produce original content, such as music, pushing the boundary of creativity. So now, you may say, how does you use Gen AI for your application? We work with a lot of customers, and I think it's fair to say almost every organization understands the value of generative AI. And they're good at outlining the strategy for the organization. But what we have found is almost everyone that we talk to really only focus on the foundation model or the large language model. But what's more important, this is just the tip of the iceberg. So beneath this complex ecosystem of data management, data storage, data integration, and governance, we need to make sure that the Gen AI application is efficient, ethical, and effective. That's what I call the 3E. To elaborate a little bit more, generative AI application is still application. So you still need your operational data to provide the context for your Gen AI application. You still need the streaming and the batch and the interactive analytic to collect, store, process, and visualize your data. While you may think this is, so in the end, it's really the data processing and the usage that you need to nail down to get where you started. So in this sense, a modern data architecture will help you innovate faster. And let's explore why and how. In fact, according to a recent McKinsey report, companies that have not yet found a way to effectively harmonize and intersect the data, they won't be able to fine-tune the data to generate some more of the innovative use case for the Gen AI application. This requires a clear understanding of your data and infrastructure strategy. So you may ask, why does data matter so much? When you want to build a Gen AI application that is unique to your business, unique to your end users, your organization data is your key differentiator. When you think about it, almost every company has access to the same foundation model. But companies that will be successful are the one that is using the Gen AI inclusive of the organization data. In doing so, they will understand the customers and the business needs. Data is the difference between a generic Gen AI application and the Gen AI application that understands your business and your customer deeply. But using data for Gen AI doesn't mean you have to go and build from scratch. So while some company may train on a very large language model, we have worked with organizations that use base out-of-the-box foundation model and fine-tune it with their own organizational data, or use what we call by acting context with the RAG, Retrieval Augmented Generation method. So let's look at a bit in more detail. So if you're a travel online agency and you want to generate personalized customer profile in your database, as well as to provide some recommendation based on the historical past trip, the web history, and travel preference. You will also want to marry that data with external data such as the flight details, hotel accommodation, promotion, so that you can provide similar travel detail. One customer that is an example of this is Booking.com. Booking.com has been using AWS for its operational, analytical, data storage, machine learning capability to build their own model using SageMaker. And at reInvent 2023, they actually shared with us how they actually use Amazon Bedrock to include some of the organization data to fine-tune the recommendation for their own end users. Now, we have seen the powerful capability of GenAI that's able to create content. But what's more important for your organization is you may want to incorporate your own branding, right? Your brand guideline, your brand guidebook, your previous ad history, and content from your data lake. So this is where you actually create content that is as unique as you want it to be for your end customers. Of course, when we talk about GenAI, a lot of people tend to think about intelligent chatbot, but what makes the GenAI chatbot powerful is how we can now leverage structured and unstructured data source, such as your Slack, such as your SharePoint, such as your internal guide, and to make it more informative. So there are several ways that customer can actually start leverage data in a GenAI application, starting from the easiest to the most complex to implement. And going to the most complex usually means you have to build a more purpose-built for your business need. So let's walk through this in a little bit of detail. So we talked about RAG, right, which is customizing the model output based on your organization data to augment that before you actually generating the output back to the users. So this method is what we call the retrieval augmented generation. So RAG actually help the model to adjust the output based on the data retrieved as needed from your organization, for example, data store, data warehouse, or data lake, or even unstructured data. Now let's look at a little bit of example. So this is going to be a simulation of a RAG pattern for a Gen AI conversational chatbot for insurance company. The application is used by this insurance company to generate insurance coverage quote for the users. Now, if you look at the prompt exchange, we will be identifying some of the situational context, such as who the user is, the user's address, the type of car that the user is driving, and the number of family household that the person wanted to add to the insurance. Now, once we have identified the situational context, we are now using RAG behind the scene to augment the query against the insurance marketplace to generate the insurance quote for the users. Now, let's walk through a data representation flow of this RAG system. So here's what's happening behind the scene. A user submits a question or statement as a prompt, and then from the prompt, the keyword get extracted and be used to retrieve relevant data because from the enterprise data store, such as the data warehouse, data lake, or the Victor database. And then the data warehouse will actually send this off data, provide additional context. This now gets sent to what we call the large language model with the situational context. And now submitted to a large language model. And the large language model will be able to now generate a more richer and contextually relevant information back to the user. Now, we talked about the data warehouse, data lake, but there could also be images, video files, or document that an organization wanted to bring that in together. So this data is what we get stored in what we call the Victor store. Now we hear a lot of RAG, we hear a lot of Victor embedding, so what it is. So imagine as human, we understand words, we understand relationship, but for computers, it's all have to be represented in numbers. So vector embedding are just a way of saying we're converting that images, text into relationship by converting the data into a numerical representation to capture the meaning and the relationship. Now, this process of vector embedding include the following. So first of all, we have to ingest the data from the source, and then we need to split it into a manageable chunk, which is called the tokenization, which are then transformed into what we call vector. So vector is a high-dimensional numeric construct, and this numeric construct then gets stored in our vector database. And this vector database will measure the distance between the two vectors that will help to generate that similarity search, which make them ideal for the large language model-based application. Now, when we, at a very high level, for the application that we sampled, that we looked at, the RAG architecture will look like this. But basically, you may say, what kind of data store or the data processing do we actually need? You will notice now here we have two sides of the story. On the left-hand side, now we have the end-user critical path. This is where the user actually interact with the GenAI application and get the response. And behind the scene, there's a complex system of streaming data update, batching data, getting the data ingested. But now you may want to ask, so where does RAG fit into this? So RAG is the pipeline that delivers the semantic context to the interaction. There's a lot more architectural components are involved, but let's look at the end user critical path. And of course, beneath of all this, we have our data ingestion and most importantly, the data governance. And for those of you who wanted to learn more about data governance, we have a whiteboarding session right after this. So now, in terms of the end user critical path, the flow is as follows. So user asks a question to the GenAI. The GenAI get the conversation history. And then the GenAI will work to break that down into situation context. That's when we actually break it down into what's the users, how many, the name, the address, and the type of card. And that's what we mean by the situation context. And then we actually tokenize a prompt. Remember what I mentioned about tokenize a prompt. So basically, we're chunking the prompts that we feed in into manageable pieces, and then sending that back and run a similarity search at our vector database. And then call the large language model with what we have engineered in the prompt. And then we update the chat history and return the response back to the users. So I talked a little bit about vector store, right? So to support your vector search requirement at AWS, we have, again, like we have different purpose-built vector store as well. So if you are looking at search, we have the Amazon OpenSearch and the Amazon OpenSearch serverless that will support the KNN, which is the K-nearest network, as well as the neural search plugin that you can use. And it will do the vector embedding on the fly. For relational databases, we have PostgreSQL and the Aurora or the RDS with VG vector plugin. So for those of you that are familiar with relational databases, RDS will be the way to go. And for document databases, we have vector search for DocumentDB, as well as the key value store, which is DynamoDB with the ETL, with zero ETL back into the OpenSearch. Now, finally, we talked about a lot of the relational databases, non-relational databases, right? And these are the engine to support your enterprise data store. If we look at relational databases, for customer wanting to move away from self-managed databases such as Oracle, SQL Server, MySQL, PostgreSQL, and Maria database, AWS offer you Amazon RDS and Amazon Aurora. For non-relational databases, for customer wanting to move away from self-managed, non-relational document and key value store, such as MongoDB, Redis, Memcache, and ElastiCache, we have the DynamoDB, DocumentDB, ElastiCache, and Amazon Keyspaces. And for those customers who want to move away from self-managed proprietary data warehouses such as Teradata, Oracle, and SQL Server, we have the Amazon Redshift. So just like everything else nowadays, the building block of GenAI application are actually powered by data, your data. And data that is typically stored across multiple data store, across multiple data format. And data need to be unionized and intersect before you can get to a meaningful state to do any GenAI application. And data that is valued when it is consumed fresh or at almost near real time with high confidence of data quality. So to bring this together, a fully governed, fully integrated, and well-governed mean that you need to have a comprehensive data architecture behind the scene to collect, analyze, and feed that into your GenAI. Now, we talked about some of the batching and streaming for the near real-time data. So this is where we actually have the data to be processed in near real time. And then we also have to make sure that we have a system that can store the conversational state for your GenAI application. Of course, and then we need to actually have the data warehouse to provide that situational context where the vector embedding can actually go and chat to. And this is where we actually need a vector data store to store all those numerical high dimension representation of the vector data. And lastly, we need to have like a comprehensive, integrated cataloging, ETL, and data management to bring everything together. Now, we talked about streaming and processing at AWS. We have what we call the Amazon Managed Streaming for Apache Kafka. So that is actually, you can use that managed service with a full support of Kafka workload, and that's actually support data replication across the cluster. We also have the Amazon Data Stream that gives you the capability of streaming almost like near real-time service for moving the data off from the producer. It's actually serverless as well, and it provides you the short and long-term data retention as you need as well for your streaming data. So next, we also need to have the ingest and process for streaming. So we have the Apache Flink as well as EMR. So Amazon EMR is a big data platform, which is allowing you to spin up the EMR cluster and running some of the open big data frameworks such as Spark and Hive. So from an integration perspective, we have AWS Glue. So Glue is our serverless offering, our data integration tools that build on top of Apache Spark and actually facilitate the implementation of ETL and the data quality measurement. It also provides you the capability of doing data cataloging, and you can actually centrally store your metadata just like a schema. Now with Data Lake, we have our simple storage service that provides you with the industry standard of scalability, security, and durability as our S3 Data Lake. Now, that's a lot of things that happened in the last 10 minutes. So, and we have only just covered the RAGs, which is one of the easiest way to specialize our large language model over your own data with a combination of pre-trained large language model with your internal, external searchable knowledge base. Let's look at the other two patterns. So the other two approach that we have seen customer adopting is fine-tuning a pre-trained model. So this is where you wanted to have a pre-trained model, but to train it even further with a smaller labeled subset to customize your unique domain needs. And you may, for some of the customers that we've worked with, because of the very special unique need, they need to actually train the model from ground up. And this is where they actually build their own language model from ground up, and they are very purpose-built. We will cover these two architecture behind the scene together because both of these are very similar to the RAG approach. So just like what we've seen before, this should look familiar to you. It is the same, pretty much the same as the RAG architecture that we have talked about earlier. But what you have seen in here, we will still need to have the data collection, data processing and data analyzing to feed our GenAI application. We still need to have the data pipeline to provide the data to the GenAI. And behind this, but what's the difference here is that we do not need to have the vector data store, because when in the method of fine-tuning and training your own model, the language processing is almost the contextual, is built in the model, so to speak. So you don't actually have to have a vector data store. So I guess after knowing those architecture patterns, the question that we have is, so how do we take that GenAI application and scale it, right? So, and the easiest way to build and scale your GenAI application is with Amazon Bedrock. Amazon Bedrock is a fully managed service that gives you a choice of high-performing foundation model from a variety of leading AI company as well as Amazon's own, with a broad set of capability to allow you to build that GenAI application. So with Amazon Bedrock, you can actually experiment a variety of foundation model for free. So just go into the Amazon Bedrock playground and you can play it for yourself to see what models you need. You can also customize it privately, like I mentioned before, using the techniques such as RAG or even the fine-tuning and retrieve and the RAG purpose. With Amazon Bedrock, what's cool about it is that you can actually create managed agents. So let's just say in the example of travel industry. So we just create a knowledge intelligent bot. What we can do as well from retrieving the data, we can actually create something called an agent that allows you to create the booking travel, to create the processing claim. Now, what I wanted to highlight the fact is we talk about the three different models, the RAG, fine-tune, and build your own model. And I wanted to highlight the fact that you can actually mix and match. You can have your RAG as well as fine-tune depending on your business need. So we have knowledge base for Bedrock which support the entire workflow. Now, I talked about RAG before. A lot of the time you have to build your own vector store, you have to write your code to bring them in. But with a knowledge base for Bedrock, you simply point it to a location of your S3, and Bedrock will fetch the relevant text information and convert them into embedding on your behalf. So you don't have to do that yourself. And it store them in a vector database. So at the time of running the inference, the Bedrock will retrieve the relevant text and augment your prompt, and then tag the relevant information with source attribute. Now, it is very important to note here with knowledge base for Bedrock, we actually give you the source of where do we actually, the citation, so that you can actually have the full transparency for checking as well as minimizing hallucination as well. So the vector database supported for Amazon Bedrock knowledge base is we have our Amazon OpenSearch serverless, the Redis Enterprise, Amazon Aurora, Pinecone, and coming very soon is our MongoDB as well. So have a look at them. So AWS is a very excellent place to build your data strategy because like I mentioned before, we have a whole set of data processing, integration tools that's fully integrated so that you get a complete sense of your organization data, breaking that data silo, as well as governed as well. Like the tool that talk about the governed, so when we talk about store, query, and analyze, we actually have like a lot of different tools, the relational databases, the non-relational databases, depending on your need, as well as the S3, which allow you to act and then serve your business need as well. So when we talk about integration, it's all about how do you bring all this data, your organization data, to make it more meaningful, to create that GenAI application that is unique to your business. So this is why it's so important to bring everything together, and we have been focusing on eliminating the ETL. So we have something called the zero ETL between the Aurora databases to Redshift, and even the OpenSearch, DynamoDB to OpenSearch. So we are trying to make it as easy for you all to connect to get all your data. And in terms of governance, we need to look into a different approach. So generative AI application governance means you have to govern the AI in your data, as well as governing the usage of your GenAI application workload. And similar to what we have the end user critical path, we have the IAM that allows users to access when they can access that, as well as Cognito for sign-on and authorization. Behind the scene, we have Glue, Lake Formation, and Data Zone that provides you with that data cataloging capability, integration, and data quality. Something worth to check out is the AWS Glue that comes with data quality checks. Out of the box, there's a lot of data quality check because you want to make sure your data is of good quality before you actually feed it into your Gen AI. So with that, we are here to help. I mean, talk to any of us. I'll be at the She Builds booth just outside of Workshop 1. Come and drop by if you have any more questions. But it's so important for us all to understand how to get started. A lot of organizations that I've been talking to wanted to get started, but if you need peer executive level conversation, come and talk to use our data strategy. We also have a program called Data Driven Everything. This is where we actually work with you and identify a cool use case that your business will resonate. Usually we see customers that's been able to do an MVP, to take it back to the business, to prove the business value, they will actually get more adoption from the organization. And if you need to migrate the data, AWS Reimagine Data is the way to go. Now, as a lot of organizations go through this transformation journey, enablement is one key aspect. And I wanted to highlight the AWS Builder have over 600 skills, training, enablement that you can actually empower your organization. So do check it out. So with that, thank you so much for spending this half an hour with me. Like I said, I'll be at the She Build. For those women and underrepresented, I would love to chat to you, connect with you, to share with you what the AWS She Builds program is as well. And with that, thank you so much for spending your half an hour with me. And please give us your feedback on how the session go and what more we can do. And thank you so much. Thank you.